Hi, today I'd like to talk to you about a different way to multiply. This is multiplication by the box method. We're going to use a partial product model, but using boxes to organize our thoughts. Let me show you what I mean. Here I have 46 times 35. What I need to do is set up a box, here it is, and I need the same number of place values. I had two place values, so I had two boxes going across. And on the second number, I had two boxes going down. Looks like a 4x4 grid, kind of looks like a multiplication table. I take the value of each digit, not the number and the digit itself, but its value. This 6 is worth 6 ones. I place it here. This 4 is actually 4 tens, which is 40, and I place it here. This 5 is worth 5 ones, and this 3 is 3 tens, which is a 30. I use it like a multiplication chart, multiplying the two numbers on the outside, 40 times 30. 4 times 3 is 12, adding my two zeros. 6 times 30, well, that's 18, adding my 1 0. Remember, those quick tricks to multiplying can come in handy. 5 times 40, well, that's 20, and I have 1 0 to add. 6 times 5, 30, no other zeros. My multiplication part is done. I now need some sums going across. I'm going to add these numbers going across the page. Let's see, 1200, 1380, and 200 plus 30 is 230. Here's my partial sums. Once I add this up, I will have my final answer. 8, 9, 10, 11, 6. There is my final answer to this multiplication problem. I know some of you are saying, oh, well, the algorithm method is so much easier. This is just one more way that we can show our work. For some students, understanding the place value is much easier. Here's another example. I didn't write anything in this time. 86, broke it down into 80 and a 6. 43, here's my 40, here's my 3. So 8 times 4 is 32. I'm multiplying and two zeros. 6 times 40, well, that's 240. 80 times 3, that gives me 24 with a 0 after it. And 6 times 3 is 18. So we multiplied. We're going to add across. And thirdly, we will add down. So let's see, I've got one out of the 3 steps done. Let's multiply. Let's add across. 2, 2, 2, 3, 4, 4, 0. And if you're having trouble doing it in your head, there's no shame in writing this out. Mistakes, simple mistakes can mess you up, so why take a chance? And 240 and 18, that's 258. My work's in the way here. I'm going to rewrite this, make it a little closer together, a little less distracting. 258. And this will be my final answer. 8, 9, 6, 3. It's as easy as that. Now I just want to do one more problem, show you how it works with a larger number. I have 1,726 times 321. Again, I've put in each of the places needs its own box. It starts to get to be a quite large box. 3, well, I have 1, 2, 3, 4, 5 zeros behind this 3. 1, 3, 4, 5. 7 times 3 is 21 with 4 zeros following behind. 2 times 3 is 6 with 3 zeros following behind. 18 with 2 zeros. 12 with 1 0. 2 times 2 is 4 with 2 zeros. 7 times 2 is 14 with 3 zeros. 1 times 2 is 2 with 4 zeros. 1, 2, 3, 4. I'm going to put my commas in just to keep me organized. I think it'll help when it comes time to add. All right, one last row, we're in the ones column. There's 6, 20, 700, and 1,000. If you take a look, those of you at home used to the algorithm method, these are all the things you would be multiplying anyway when you did your traditional algorithm: 6 times 1, 2 times 2, 2 times 1, 1 times 7, 1 times 1. You're doing it out, just a different form. So let me add this across my next step. 7, 2, 1, 6. Ooh, here it comes. That's 3, 4, 4, 5, sorry, 520. I think I'll be realigning this to add it. So I have 300,000 plus 210,000, that would be 510, 516, 17, 517,800. And now I need to add my partial products. I'm going to rewrite this one a little more in line. I'd hate to make a silly mistake because of lining up my numbers. 6, 0, 2, 2 is 4, 15, 20, 2, 7, 10, 14, okay, 3, 5, 5, and my final answer can be found in that addition. Remember to set up the exact number of boxes due to the place values. Multiply each like a multiplication table would. Add across, then add your partial products down. Thanks and good luck.